Hi there. So today we are going to talk about solving and graphing two-step inequalities. And these are going to be really similar to solving one and two-step equations, just with the added fun of working on some with inequality symbols and also graphing. So let's get started by talking about some of these inequality symbols. Hopefully these should look familiar. Less than, I always think of the less than symbol. It like faces the same way a capital L would, but think about like taking that L and then like slanting it on its side. If I have the line underneath the symbol, it means less than or equal to, and then greater and greater than or equal to as well. So think about, what does this say in words? If I were to say, what does this say in words? It's x is less than 7. And x is really like a number. So it's a number is less than 7. Well, think about what that would look like in terms of my graph. What numbers are less than 7? There's not just one number less than 7. There's lots, right? 6 is less than 7. 5, 4, 3, 2, 1, 0. -1 is less than 7. -2, etc., etc. But also, what about like all the numbers? It wouldn't just be like these individual points, because there's numbers in between those points. So like, for example, a half, 2/3, 0.7. All of those numbers are less than 7 as well. So we're going to shade every number on the number line that's less than 7. So essentially, I'm going to shade every number on this number line all the way down till -infinity. So I put an arrow down there. But my question is, where should I actually start shading? Do I start at 6? 6 certainly is less than 7, right? But remember, we said there's numbers between 6 and 7. So like 6.5 is less than 7, 6.8, 6.9. So how do I, like, where do I start? How far up do I go? So what you can do is you can draw what we call like an open circle on the number 7. And then you're going to start shading at that 7. So I'm going to start with my open circle on 7, and I'm going to shade everything below it. Now, the reason I have an open circle on 7 is because I don't actually want 7 to be shaded. I don't want 7 to be shaded because 7 is not less than 7. That's not true, right? So 7, the number itself, this 7 right here, should not be shaded, right? On the other hand, if it said x is less than or equal to 7, then 7 would be less than or equal to 7. That is true. And so I would want this 7 to be shaded. So we fill in that circle. We call that like a closed circle, because again, I want anything that's a solution, I want it to be shaded. So the 7 itself, the point should be closed. The point should be shaded. All right, so here's some like general steps to solving and graphing any inequalities. So first, you're going to use inverse operations to isolate the variable. But here's number 2. This is the part that a lot of people forget. If you multiply or divide with a negative number, you must flip the inequality symbol. So if it was a less than, it becomes a greater than. If it was a greater than or equal to, it becomes a less than or equal to. And then you're going to graph at the end. And keeping in mind down here, anything that's a solution to the inequality will be shaded. So let's go through some examples. So solve and graph each inequality. So number one here is already solved for x. X is already by itself. I don't have to do any solving, right? So instead, I'm just going to graph. I'm going to draw my number line, and on my number line, I often start with 0, right? And then like here would be 1, here would be 2. You don't even need to label them, because I really only am concerned with like -1, right? So here's my number line. This says x is greater than or equal to -1. So the numbers that are greater than or equal to are all the numbers above -1. So I would shade going to the right. Would I include the -1? Is -1 greater than or equal to -1? It is. So it should be shaded. So I don't have to do anything to solve. This is kind of like my solution already. And then this is my graph. In other words, any number that's in the shaded region is a solution. So 0 is in the shaded region. If I plug in, 0 makes that true. 1.5 is in the shaded region. That makes that true. But anything not shaded, so like over here, so like -2, that does not make that true. That's not a solution. All right, let's go on to number 2. So number 2, when we solve, we have -2 times x is less than 10. To solve, we would divide both sides by -2, right? And when we divide by a negative number, because this 2 is negative, because I'm dividing by a negative number, I have to flip the inequality symbol, and that flips to a greater than, and 10 divided by -2 becomes -5. So x is by itself, that's my solution. Now let's graph this. So again, I can start at 0, 1, 2, 3, 4, -5. And this to me says x is greater than -5. So I'm going to start at -5. And everything greater than -5, everything greater is like -4, -3, -2, -1, 0, 1, 2, 3. So it's everything to the right. And now, should I shade that -5? If I plug in -5, that's not true. -5 is not greater than -5. So I should not shade that point. It should be what we call like an open circle or an open point. Rule of thumb, and you might want to jot this down. If you have a less than or equal to or greater than or equal to, you're going to use a closed circle. You're going to shade in the circle. If you have a less than or a greater than, you're going to have what we call like an open circle. You're not going to shade it in. All right, number 3. Let's solve and graph. So number 3, I would divide both sides by, to solve for x, I would divide both sides by 3, right? And 12 divided by 3 is 4 is greater than or equal to x. Well, now, I'm going to draw my number line. Here's a 0. Now I need 1, 2, 3, +4. And now think about this. It says 4 is greater than or equal to x, or 4 is greater than or equal to a number. So 4 is greater than or equal to what numbers? Well, 4 is greater than or equal to like 3, 2, 1, 0, and all these negatives. So we would actually shade over here. Think about my rule. Would the 4 be shaded in? Would the dot be closed or open? It would be closed because of this or equal to part. Now, I want to show you something. One thing that you may have noticed, going back to number 1 and number 2, if I think about this inequality, let me erase this, hold on. If I think about this inequality symbol right here, this is a greater than. But which way, if you think about this as like an arrow, this is a little trick I'm about to show you. I shaded the way the arrow was pointing. So the arrow was pointing to the right, I shaded to the right. Number 2, it's a less than symbol. The arrow was pointing to the left. Notice it flipped, it flipped. So, hold on. It flipped to a greater than. The arrow is pointing to the right, I shaded to the right. In this case, this inequality symbol is pointing this way, but I shaded in the opposite direction. And that's because, notice where the x is. Where's the variable? The variable in this case was on the right-hand side. The variable over here was on the left-hand side. So a little trick that my students sometimes use is to shade the way the arrow is pointing. but that's only true if the variable's on the left-hand side. So let me show you what you can do in number 3. In number 3, we solved, we got 4 is greater than or equal to x. You can literally flip this and put the x over here and the 4 over here, but if you flip, you have to flip the inequality symbol as well. So it's x is less than or equal to 4. I notice that my students a lot of times like to have the variable on the left. They like to read it that way. So I would suggest if you get your answer and your variable's on the right, to flip it and put it on the left. But when you flip it, you have to flip the inequality. All right, let's go on to number 4. So to get x by itself, we're going to subtract 6 from both sides. 8 minus 6 is 2 is less than x. Now, this is that like issue that I was saying before about like number 3. My variable's on my right-hand side. I could leave it like that and graph it, or I could flip the x and the 2. But when I flip the x and the 2, what do I have to do? I have to flip the inequality symbol as well. So x is greater than 2. All right, here's my graph, 0, 1, 2. X is greater than 2. Now I can use my little trick I taught you. Because the variable's on the left-hand side, I can shade the way the arrow is pointing. So I'm going to shade to the right. 2 gets an open circle because there's no like or equal to part. So this is what my graph would look like. All right, number 5. I have negative 3x is greater than 9. This means negative 3 times x. So to undo multiplication, I'm going to divide both sides by negative 3. Negative 3's cancel. I have x is less than, and I flip it to a less than because I'm dividing by a negative number. So it's whatever I'm dividing by or whatever I'm multiplying by is negative. Okay, so I flip it to a less than. 9 divided by negative 3 is negative 3. And then I graph. So 0, negative 1, negative 2, negative 3. This is a less than, not a less than or equal to, so I would have an open circle. And if x is less than negative 3, I would shade down to the left. So again, think back to like what we said about solutions. Anything that's shaded is a solution. So if I were to say to you, is 0 a solution? You'd be like, well, here's 0, it's not shaded. So no, it's not a solution. But also I could plug it in. That's not true. 0 is not less than negative 3, right? All right. Let's go over to number 6. So now in number 6, I have to get rid of this plus 3 first because SAD math. When I solve, I follow SAD math. I'm getting rid of my subtractions or my additions first. So I'm going to subtract 3 from both sides of the inequality. I can draw that little line if I want to. 3 minus 3 cancels. I have negative 4x less than or equal to 6 minus 3 is 3. Right? And then I want to get x by itself. So this means negative 4 times x. I divide both sides by negative 4. What am I dividing by? I'm dividing by a negative number. So if I'm dividing by a negative number, I have to flip that inequality. So x is greater than or equal to, and 3 divided by negative 4, that doesn't go in even, so I'm going to leave it. Fractions are my friends. So my answer is x is greater than or equal to negative 3 over 4. I'm going to draw my graph over here. I'm running out of room. Okay, so it's a negative number, so I'll start at 0. If here's negative 1, negative 3 over 4, you can use your calculator if you want to, but it's like negative 0.75 or negative 3/4. So it'd be like negative 3/4, like somewhere like there. We're not going to find it exactly, but it should have a closed circle because of the or equal to part. So closed circle. The variable's on the left side, so I can shade the way the arrow is pointing. I can shade to the right. X is greater than or equal to negative 3 over 4. Think about it. Is 2 a solution? Well, 2 would be here, right? 2 is in the shaded region. If I plug in 2, is that true? It is. So 2 is a solution because I can tell it's in the shaded region, but also if I plug it in for x, it makes the inequality true. Okay. So now's a good time for you to try some practice problems on your own. So here's 6 more problems. I would pause this video and try these on your own. And then when you unpause, I'm going to quickly give you some answers and go through some of these with you. Okay, so now that you have gone through some of these problems on your own, let's check to make sure you did them all correctly. So ready? Number 7, I would get x by itself by adding 7 to both sides because negative 7 plus 7, that cancels out. I have x is greater than 10 plus 7, which is 17. Now, x is by itself. I like this answer because the x is on the left-hand side. I don't need to draw 17 tick marks. What I can just do is like start at 0 and go up to 17. My circle is going to be an open circle because I don't have the or equal to, the line underneath the inequality symbol. And its x is greater than 17. And so I'm shading to the right. All right, number 8. I should have divided both sides by negative 3. When I divide by a negative, I have to flip the inequality symbol. So it becomes a less than or equal to, right? So that's what you should have gotten when you solved. And then when I go to graph 0, 1, 2, 3, 4, 5. Okay, so negative 5, this will be a closed circle because of the line underneath. And its x is less than, think about what that symbol is called, less than negative 5. Where's less than? It's to the left, but I can also check because I'm shading the way the arrow is pointing, right? All right, number 9. To get x by itself, I have to get rid of SADMAP, my addition or subtraction first. So I have to get rid of that plus 8. I'm going to do the opposite operation and subtract 8. This is 12 less than or equal to 4x. Now I get rid of that 4 by dividing both sides by 4. So 3 less than or equal to x. And I don't like that because the x is on the right-hand side. So I'm going to flip the x and the 3 so that the x is on the left. But remember, if I flip the sides, I also have to flip the inequality. So my answer is x is greater than or equal to 3. Now listen, just a quick reminder. You could have left this as your answer. That would have been fine. But either way, when you graph, your graph always would look the same. It would be a closed circle, and its x is greater than or equal to 3. Or even if I read this, it's 3 is less than or equal to x. Well, what is 3 less than? 3 is less than like 4, 5, 6, 7. So, you know, I would shade to the right there. All right, number 10. Oh my gosh, I have a fraction, but that's okay. This just means divided. Like a fraction is just division. X divided by 4. How do I undo division? I multiply both sides by 4. I'm going to multiply this by 4. Those cancel. I have x is greater than negative 8. Now, even though my answer is negative, I don't flip the inequality because what did I multiply by? I multiplied by 4. And 4 is a positive number. So if it's a positive number, I don't flip the inequality. I only flip the inequality if I multiply by a negative, like in number 8 there. All right, I like this because the x is on the left. 1, 2, 3, 4, 5, 6, 7, negative 8. And then I have an open circle, and then it says x is greater than negative 8. So I would shade going that way. Number 11, to get x by itself, I would get rid of SADMAP, right? I might get rid of my addition or subtraction first, so I should have had negative 6x less than or equal to 24. Now I'm dividing by negative 6. Ding, ding, ding. I'm dividing by a negative number. So now I do flip the inequality. It becomes a greater than or equal to. And then 24 over negative 6 is negative 4. So look, in number 10 and in number 11, my answer was both negative, but I only flipped in number 11 because I divided by a negative number. All right, so here's 0, negative 1, 2, 3, negative 4. And it would be a closed circle, and it should have looked like this when you graph. All right, last but not least, number 12. So number 12, get x by itself, SADMAP. I'm getting rid of this positive or plus 10, so I need to subtract 10 from both sides. Subtract 10. 10 minus 10 cancels, right? Wait a minute, I have 10 minus 10 on the left as well. That cancels, or in other words, it gives me what number? 10 minus 10 is 0. Don't be afraid of zeros. So I have 0 is greater than negative 5x. To get x by itself, I have to divide by negative 5. So I have x is, I'm dividing by negative, so I flip the inequality. 0 divided by negative 5 is still 0. So I could either circle this, or remember we said we could flip so that your variable's on the left-hand side, but I flip the inequality. So either one of these, you don't have to have both, but either one is fine. Now I only need that 0 on the number line. It gets an open circle, and what numbers are greater than 0? These numbers over to the right. Okay, so now you know how to solve and graph 1- and 2-step inequalities. Thank you so much for watching.